Is it continuous everywhere?
Yes.
Continuous everywhere, or negative infinity to infinity. Does this function, when we graph it, does it have a corner? Does it have a cusp? Does it have a vertical tangent?
No.
No. It does not have a corner. It does not have a cusp. It does not have a vertical tangent. It has a minimum value, smooth, continuous function, no corner, no cusp, no vertical tangent. So this function should be differentiable, should have a rate of change, a slope of the tangent line everywhere. Would you agree? So we will be able to find, so we're asked to find the derivative of this function. What will this give? At this point, it will give us the slope of this. At this point, it will give us the slope of this line, tangent line. At this point, it will give us this slope of this tangent line. At this point, this, and so on and so forth. But we have to find it first. And then you can say, find the equation of the tangent line here when x is 3. I will be able to. I will be able to find the equation of this line, which is also a big deal in calculus. Okay, so let's find f prime first. We do not know differentiation rules yet. We will in chapter 3. So right now, we're going to go through, so we are asked to find f prime. So I have to write f prime of x is the limit as age approaches 0 from the difference quotient f of x plus h minus f of x divided by h. Okay, now this piece is very clear. It's x squared plus x plus 3. This piece is just the little h, if you remember, is the tiny difference between those points on the x-axis. But I need to determine this for our function. Can anyone give us this for our function before we start? Just
And that would be x plus h squared
very
plus x plus h plus 3.
excellent. And please don't forget that this has 3 terms, which are x squared plus 2xh plus h squared plus x plus h plus 3. So now I have all 3 pieces. I prepared the function, the pieces, and now I'm ready to find f prime. So f prime of x, I start from scratch with limit as age approaches 0. Watch me run out of room. So this is all this. 2xh plus h squared plus x plus h plus 3. Do not forget that the negative symbol has to be distributed. So negative x squared minus x minus 3 divided by h. What has to happen now? The first step. What has to happen and what is the second step? I'm sorry, I didn't mean to, you may want to copy. So at this point I have to think. What has to happen that we discussed several times inside the difference quotient before we even talked about the limit? 2 things have to happen. What is the first one?
Do we need to find the like terms that are going to cancel out?
Correct. But what has to happen? Otherwise, I know I have an error.
Find where it's undefined.
No.
What was the question again?
2 things have to happen at this point. Okay, let's write them down again. This is super important. Number 1, all terms without h must simplify in the numerator If they don't, this has no meaning. I have made terrible mistakes somewhere. If not all terms with, maybe some terms with age cancel out, that's even better. But if not all terms without age do not, if they do not go away, then I have to start from scratch. They do. In step number 2, age in the denominator must go away. Age in the denominator must simplify as well. It's a must. So I see 3 terms. Do not simplify in a sum. If you simplify, and I saw some of you are simplifying in a sum. It breaks my heart to see that. Please. Please, in my class, you will learn algebra, you will learn pre-calc, and you will learn calculus if you stay on track, and please. So, how do I continue? These 3 terms have age in common. So, I write the limit, do not drop the limit operator, and age gets pulled out. So, what am I left with when I pull age out from those 3 terms?
Age plus 2x plus 1.
So 2x plus age plus 1. Awesome. So 2x from here, and age from here, and a 1 from here. 3 terms. If I have 3 terms, I have to have 3 terms. Okay, so here it is. And it does. Remember, we have to get a function. Can anyone, now I drop the limit operator because I apply it. What do I get? Can anyone give us the answer? It must be a function.
2x plus 1.
That's it. Thank you very much. When age approaches 0, so 2x plus 1. Again, what is all this? It's a function that gives the instantaneous rate of change of f of x at any point, only where the function is differentiable. It doesn't have a cusp, corner, vertical tangent, or it's not continuous. So here's a question. Continuity implies differentiability? Can I say that if a function is continuous, it must be differentiable? Question. Second question. Can I say that if a function is differentiable, it must be continuous? Which direction, or both?
You can say that you can't say it's differentiable if it's simply continuous. But
Excellent.
You can say
Only
that
this way. Thank you, Katie. Only this way. Because we already know if the function is not continuous, it cannot be differentiable. But if it is differentiable, if I say it's differentiable on all real numbers, then it must be continuous on all real numbers. It couldn't be differentiable otherwise. So if a function is continuous, it's not guaranteed to be differentiable, but if it is differentiable, it's guaranteed to be continuous. Any questions? Any questions? And there is one thing that I forgot from the previous section. I mentioned it, but I forgot to talk about arctangent. So please, I just want to graph it. So arctangent, remember, is tangent inverse of x. Not to be understood as 1 over tangent x. This is not that. How will I rewrite this? Potentially as tangent x to -1 like this, not like this. So these mean the inverse function of tangent x. I just want to refresh your memory on the graph and talk about the limits at infinity. We need this. So this is the graph of arctangent x. Arctangent x. I prefer this notation. Typing it, it's easier, and also there is no ambiguity. For some students, that is okay. So this horizontal asymptote is y equals pi over 2, and this horizontal asymptote is y equals negative pi over 2. So notice that this function does not have the same horizontal asymptote at both ends. It has pi over 2 here, but it has negative pi over 2 here. So the limits, please remember these. The limit of arctangent x as x approaches infinity, and the limit as x approaches negative infinity from arctangent x. What will you say?
For arctan x as x approaches infinity, it would be pi over 2. And then for the other one, it would be negative pi over 2.
Which means the horizontal asymptote is here, and this is the horizontal asymptote here. Okay, I would like to analyze a graph and come up with a sketch. So I'm hoping that you finalize this. If you want to upload, just upload any of the last problem, either this part or this part. I just want to make sure that you didn't drop the limit operator and you wrote down those two notes. These are our checkpoints. If these two things do not happen, I will immediately realize that I made a boo-boo here somewhere. Something is wrong. If h does not cancel in the second step, and if all terms without h do not simplify in the numerator, then I know I have a boo-boo. And I have to do something about it and go back to the drawing board. Should I wait?
Yes, please.
Okay. Anything about that function that we came up with? I think Sean came up with it. It was very good. And we determined the derivative using the definition of the derivative. And then I would like to look at a graph. I'm going to graph a function. Let me see if I can. Print out. Are we okay? Do we need more time? Yes, are we completed that? Yes? Is anyone with me?
Yes, I was able to complete it.
Okay. Okay, so I'm printing out. Dylan, I'm sorry I stole your graph from 2.8. It's probably the same graph, and probably the questions are different. So I'd like to talk about that graph. And I just would like to print this out. So it's coming, it's coming. Okay, so here we have a graph of a function. And what we would like to do here is determine the derivative of this function, or create a graph, an approximate, gross approximation if you want, of, and I will graph exactly underneath, exactly continuing the y-axis, and somewhere the x-axis. So what I'm trying to do here, okay, let me